Hello and welcome, I'm your CodeMonkey. In this lecture we're going to see a quick overview of the entire course from start to finish. Alright, so here's every lecture and what we're going to learn in each of them. Starting from the very beginning, first we're going to learn what is C# and what are the many use cases for it. Then on the Getting Started lecture, we're going to install Visual Studio, which is where we're going to run our code. Then we're also going to install Unity and learn the Unity basics. This is an optional step, but it's important since the interactive exercise and quizzes, those exist in a Unity project. After that, we're going to load up that project to see how the interactive exercises work, and then is a really useful lecture covering some very common errors. You should refer back to this one whenever you encounter some issues. After that one, we can finally start writing some code, beginning with the absolute basics, learning how the code is written, how it executes, what is a code block, and how code is case sensitive. Then we're going to learn about variables. These are containers for data. The data needs to have a specific type, so then we're going to learn about the various built-in data types, things like int, bool, string, and so on. Next, we're going to learn about if statements. This is a core pillar of any programming. These are conditions which affect how your code will execute. After that, we'll learn a different way of handling conditions using a switch statement. Next, we'll learn about another core pillar, functions. This is how we can place logic in separate functions and call them when needed. After learning about functions, which involves different code blocks, then we are going to learn about variable scope, which is basically from where that variable can be accessed. Next, we'll learn about comments. The syntax for this one is actually really simple, but it does bring up a lot of interesting questions regarding writing good, clean code. Then we're going to learn how to store multiple pieces of data in one container using arrays and lists. Afterwards, we're going to learn all about loops. This is how we can run certain logic multiple times, like for example looping through all members of a list. Then another crucial pillar of object-oriented programming, we're going to learn the basics of classes, how to define one and construct it. Next, we will be ready to learn about static, what is the difference between making something static and non-static. Then learn about access modifiers. This is another one that is super simple in terms of syntax and extremely important in terms of learning to write good, clean code. After that comes one of the most important lectures in this whole entire course. It's a lecture on naming rules and how you should be very careful and very deliberate about the names that you use in your code. And after that is yet another extremely important lecture, this one covering the theory behind why you should write good clean code, as well as some nice simple guidelines that you should follow. With all that done, we will have learned the absolute basics, so we will be ready to inspect a nice beginner project that involves everything we learned in this section. All of that makes up the beginner section, and afterwards comes the intermediate section. We're going to take things up one level and learn some more complex stuff, beginning with something very important that I debated whether I should put in the beginner section. It's going to be Visual Studio Shortcuts. I end up putting it here because for beginners, technically it's more important to learn how to write the code, and it's not as important to be extremely efficient with how fast you use your IDE, but for intermediates this is a must-have. So we're going to learn about a ton of shortcuts to help you write code and navigate your environment much better. Then comes one of the most important lectures in this whole intermediate section. It's all about refactoring. This is the process of rewriting your code to make sure it is as readable and understandable as possible. As an intermediate, you absolutely need to know that this is a natural part of the code writing process and something you should not skip. Next is a lecture on enums. Pretty simple and very useful. It's how you can define a specific list of values that you can use in many ways. After that, we'll learn about properties, which are kind of like a mix between variables and functions. Then we're going to learn about multidimensional arrays, meaning arrays that can hold multiple dimensions of data. After that, we're going to learn about nested loops, which is especially important in order to cycle through multidimensional arrays. Next, we're going to learn another method for doing some looping logic. We're going to learn about recursion. This is something that, for people with a math background, it might actually be similar to understand than regular loops. Then we're going to learn about an extremely useful data type, the dictionary. This is a key-value pair that has tons of really awesome use cases. After that, we're going to learn about some more collections like queue and stack. Then we're going to learn about the params keyword and what exactly does it do in a function. Next, we'll learn about optional parameters, how to define them and how to call them from a function. Then another crucial lecture for intermediates. This one is on learning the differences between value and reference types. This is extremely important. If you don't know this difference, then you will go crazy at some point in the future, wondering why something isn't changing, and it's usually going to be because you don't know you're working with a copy and not a reference. Related to that is the lecture on structs. These are similar to classes, but importantly, they are a value type. Next, we're going to learn some more intermediate use cases for classes. We're going to learn about inheritance, polymorphism, and a bunch more. Then learn about interfaces. This is one of my favorite features of C#. It allows you to write some really nice modular code. Related to that, we're going to see various ways of testing for types and converting to and from various types. Also related is the lecture on switch pattern matching. This is a really simple way to do a switch, not just on value, but also on type. Then we're going to learn all about delegates, lambdas, and anonymous functions. This is how we can store a function itself inside a field. Next, we're going to learn the differences between lambdas and local functions. After that, we'll learn about events, which is how we can have one class be notified when something happens. Then the next lecture, that one is going to be all about generics. This is another super powerful C# feature that makes your code work with multiple types. Next is a simple lecture on constants and read-only, what they are and what are the differences between those two. After that is a lecture on exceptions and how to handle them with a try-catch. Then a lecture on implementing IEnumerable, so we can add support for something like a for each for some custom types. Next, we're going to learn about namespaces, what they are and how to make your own. Then a really important lecture on one of the most important design patterns, the singleton pattern. And after that is a general overview of a bunch more design patterns. And finally, after doing all of that, we're going to check out the intermediate project that uses all of this to make something really interesting. That concludes the intermediate section, and afterwards comes the advanced section. This one covers lots of interesting C# topics. We're going to start off with an interesting advanced topic that I actually only started seriously using just recently. It's reflection. I had to learn this myself in order to make the exercise for the companion project. Reflection is how you can dynamically inspect your code and work with it without directly calling any functions or reading any fields. Next is going to be a simple but interesting one. It's how you can make some function extensions. This allows you to extend a type with more functions without having to modify that type itself. This is really useful when you don't have access to the type itself, when you don't have source code access. Then we're going to learn about static constructors. These are kind of like the normal constructor, but they run just once for the entire class. After that, we're going to learn about the type of keyword. This lets us get a system.type object of any type that we have. This is very important to use alongside reflection. Then a lecture on name of. This one helps you get a string name for some kind of type. This is really useful to help you avoid strings in your code. Next is the size of operator. This one lets you get the size of your types. Like for example, you can see how an int is 4 bytes, a short is 2 bytes, and a byte is just a single byte. So this helps you know how much memory your code will use. Then a lecture on default. Simple and very useful way to get the default value of some type. If you do the default of an int, you get 0. If you do the default of a bool, you get false. If you do the default of some object, you get null, and so on. So using this keyword is much better than hard-coding some default values. After that, we're going to have a lecture on expression-bodied members. This is a really interesting, very compact way to write simple short functions. There's no need to write all the usual function boilerplate code. This one is basically just a lambda. After that, we're going to see a lecture on records. This is a super simple way to create immutable types to organize your data. Next, we're going to learn about the null conditional operators. This is how you can easily test for null before doing something, like for example, before firing off an event. Then a lecture on the null coalescing operator. This one lets you quickly test against null, and if it is null, return a default value. After that, we're going to learn about the ternary conditional operator. This is an excellent, super compact syntax for making a very simple if. You have the condition with an if and an else, so it's all very tiny, very useful. Next, we're going to learn about the main function in a console app and how to pass in some command line arguments. This is a really important one because there are many interesting programs that you can build that don't need any kind of UI. So a simple console app that you can control with some command line arguments, that one is always going to be an excellent option. Then a lecture on nullable. This is how you can make any type support null. Even value types like int or bool, you can make them nullable to support null. This can be much better than having to predefine some special value, something like -1. Next, we're going to see a lecture on span. This is a super efficient way to do logic on arrays or slices of arrays. Importantly is how this does not actually create any new data. It does not cost any new memory, does not create a new object. This one is basically just a pointer, meaning it is insanely performant. Then a lecture on bitwise operators. This is how you can work with individual bits of data. In this lecture, I'm also going to teach the basics for how binary works. Next, we're going to learn about enum flags. This is how you can turn your enums into bit masks, which then allows you to make some interesting combinations. Then a lecture on preprocessor directives. With this, we can give orders to the compiler itself. We can define symbols and include or not include some code in the compilation. Next, a lecture on the keywords ref, out, and in. These are really useful. They help you get more data out of a function than just a single return type. And they also help you work with types as references, even if they are value types. After that, we're going to learn about data boxing. Now, this does not have anything to do with punching people. It's really all about putting data inside a box. This is an interesting property based on the fact that everything in C# extends from object. Next, we're going to learn about dynamic. This is a really interesting, very advanced topic. With dynamic, we can work with types that don't actually exist. So we can define something as dynamic and call functions or read fields on that type, on that object, even if they don't really exist. That validation logic is only going to run at runtime, not at compile time. So this dynamic, this is really useful, especially when working with data you got from some kind of web server. Then a lecture on the class indexer. With this, you can make your own custom types, support access through an index, just like a list or array. You can add whatever logic you want and make it read-only or read-write. Next is a lecture on attributes. With this, you can add metadata to your code. Then that metadata can represent whatever you want. You can use reflection to analyze it and do something to it. After that is a lecture on anonymous types. Really interesting, quick way of organizing some data without having to first define a specific type. You just do new, open up the curly braces, and it will automatically create a generated type. Related to that is the next lecture on tuples. These are very similar. They also allow you to organize some data without first defining a type. In this lecture, I also covered the differences between anonymous types and tuples. Next is going to be a lecture on using IDisposable. This is a really interesting code block and interface that helps you make sure you don't forget any kind of cleanup code. After that, we're going to learn how to create custom override operators. Using these, we can add support for our own classes to do things like addition or multiplication. We can define the logic of what exactly it means to add two custom player classes together, and also define the logic for comparing two custom types, meaning defining the logic for what exactly does it mean to do an equals. Next is a lecture on link. With link, we can easily do query operations on any collection of data, whether it be a list or array or some XML or some kind of database. We grab that data, then we can query for some conditions and select just a few elements. We can sort some things, we can do a union, and so on. If you're familiar with SQL, then LINQ will be quite familiar. Afterwards, we're going to learn about WinForms. This is how you can make visual C# programs. You have your toolbox and you just drag and drop the components. Here, I'm also going to talk about the other visual program tools, things like WPF and .NET MAUI, as well as how Unity itself doesn't have to be used just for making games. You can make normal applications with Unity. Next is going to be a lecture on DLL import, the library import, how to use extern and work with the Windows API. So this one is going to be a great lecture to learn how to interact with external libraries. Then a lecture on asserts and unit testing in general. With this, you can validate your own code to make sure everything is behaving exactly as intended. Next is going to be a lecture on writing unsafe C# code and working with pointers. Now this is a very, very advanced topic. Technically, if you know what you're doing, you can make some impressive stuff with unsafe code. But C# has a safety for a reason, so definitely only use this wisely. Then we're going to learn about asynchronous programming, specifically how to use async, await, and task. This is how you can have some code that takes some time, like for example, contacting a web server, and keep waiting for a response without blocking your program. This is extremely important in making sure your program feels nice and responsive. After that comes a super important advanced lecture. This one is all about multi-threading. This is how you can take advantage of all the cores in the CPU to make them all do work at the exact same time. When done properly, you can get some insane performance improvements, but it is also very, very easy to make mistakes. So this one is very much the definition of an advanced topic where you must know exactly what you're doing. Alright, so that's everything we're going to learn in this complete C# course. Like I've said many times, you are not expected to go through all of this in just one day or 1 week or even 1 month. It took me 10 years to learn all of this, so always remember that and take your time and really just focus on actually learning. This is your learning journey, so that's really all that matters. Take it slow, really pay attention, do all the content in the companion project, and I guarantee that if you do that, then by the end, you will have gained a massive amount of knowledge.